This lesson is for Advanced Algebra, Lesson 2.8 on Fitting a Model to Data, Day 2. It's important that when you are trying to find the relationship between multiple variables, that you try to focus on one variable at a time and hold the others constant. The book is going to illustrate this with the specific example pictured on page 121. So I want students to get real familiar with the book itself on this lesson and the examples that are given. It's important that students read the entire lesson before they get started. The video will help in their understanding, but reading the entire lesson will make the most difference. Most of the problems in the assignment refer back to the specific example, and they are not very general in nature. So students have to get to know the example in order to be successful. So let's read what it says in a real condensed version of what the book says. So far in this chapter, you've studied situations in which two quantities vary. In many real-world situations, there are more than two variables. Consider the problem of determining the maximum weight that can be supported by a board, as pictured here. Three quantities that influence the maximum weight, m, that a board can hold are the board's width, w, pictured here. Think about it like the width of a balance beam. The wider it is, the easier it is to balance. The thickness, t, and that's the smallest dimension pictured here, almost like a vertical distance, and the distance d between the supports. As the supports move closer in, the more stable the board will be. The goal is to find an equation relating w, t, d, and the dependent variable m. So again, students' goal is to find the relationship between multiple variables, and to do so, you focus on one variable at a time while you hold the others constant. The book does this for you and then simply asks questions about the different variables. So let's take a look at just the first example in the book, pictured on page 122. Some of the information is shown here. The distance between the supports is being held constant at 12. The thickness of the board is being held constant at 1.5, and then we're going to look at different widths. And so they looked at different widths of the board in inches of 1, 2, 3, 4, 5, and 6, while these other dimensions remained the same. And the outcomes that they got for the maximum weight that the board could hold are given here in the table. The table was then drawn in graphical form, and you can see that the relationship between W, the width, and m, the weight, is clearly forming a straight line, which we would call linear. So the formula we would use then to illustrate the relationship of W is that we would simply say just kW, because W is a linear relationship or directly related to the m. Moving on to the second example in the book. This time the distance remains at 12, but the width is going to remain at 2, while the thickness is going to vary. So they changed the thickness from 1 to 6, and the maximum weight the board can hold is calculated here in the table. So now you can see that the relationship here has changed to a parabola. So if we were going to write an equation that matches the parabola shape for thickness t, the formula we would get is kt squared, because t squared will form a parabolic shape. And then the last thing we need to look at is the distance between the supports. So they hold the width constant at 2, the thickness constant at 1.5, and then they change the distance between the supports. Again, the distance varies from 1 to 6. As you look at the outcomes here that are graphed, clearly that is an inverse situation. Keep in mind that we have two possible equations that could go for inverse with the distance. It could be k over d, or it could be k over d squared. So we're going to need to plug in some numbers here to determine which one is the correct equation. Whenever they give you the first piece of information where the d, or the variable you're working with, is a 1, the very next number is going to be your k value. So we can go ahead and assume that k is 212. If you plug in a 1 and solve for 212, you're just going to be dividing by 1 in both cases, and so k ends up being 212 in this particular example. So now we're going to go ahead and plug in the next coordinate and see which one gives us a true statement. So if we do a 2 for D and a 106 for M, it's pretty clear that the first equation is the one that's going to work. 212 divided by 2 is 106. So we know that it's inversely related, and it's not the inverse square. So now let's go back to our original equation. We know that it's m equals k over d. So then if we were going to put all of these together, our final result would be m equals kwt squared over d. And so that equation gives us the relationship among all of the variables, but we could only figure them out one at a time. A lot of the homework problems are going to ask you to go back through these same tables and graphs and answer questions, like we're going to do in the next two problems, numbers 3 and 4 in the homework. Number 3, what is the maximum weight supported by a board 12 feet long, 2 inches wide, and 2 inches thick? So students need to go back through the examples and look at the tables and the information given to come up with a number. It's not a calculation that's being made, it's simply searching for the right number. So 12 feet long comes from either example 1 or example 2. Let's look at what else they ask us for. 12 feet long, 2 inches wide, and 2 inches thick. So if we look at example 2, 12 feet long, 2 inches wide, and then 2 inches thick is right here. So the maximum weight that that board can hold, if we look at example 2, is 32 pounds. So that's our answer for number 3. Notice how we didn't have to calculate anything or do anything with any equations. We're simply looking through the table to find the proper set of numbers. Same thing for number 4. Maximum weight that can be supported by a board 12 feet long, 6 inches wide, and 1.5 inches thick. So let's look for a 12-foot long board again. So that would be example 1 or 2. 6 inches wide and 1.5 inches thick. So if we look at example 1, we've got the distance of 12, the 1.5, and then we can go all the way down to the 6, and there's our answer of 53. So we'll say 53 pounds there. Alright, and our last problem that we're going to do is number 6. Refer to the data for m as a function of t. Find an equation to model the data when d equals 12 and w equals 2. So if we go back to m as a function of t, that would be the second example. And we can see here that the k value, if we plug in the first coordinate, the k value is going to be an 8. And we know that it's going to be t squared. So we're going to write m equals 8t squared as our equation. And so it looks like I did get the answer correct there. Again, students don't need to calculate anything, they're simply utilizing the examples to help them answer the questions.